Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline and want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows, or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today, that's Linode, and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. When it comes to serving data for AI and ML projects, do you feel like you have to rebuild the plane while you're flying it across the ocean? Molecula is an enterprise feature store that operationalizes advanced analytics and AI in a format designed for massive, machine-scale projects without having to manage endless one-off information requests. With Molecula, data engineers manage one single feature store that serves the entire organization with millisecond query performance, whether in the cloud or at your data center. And since it is implemented as an overlay, Molecula doesn't disrupt legacy systems. High-growth startups use Molecula's feature store because of its unprecedented speed, cost savings, and simplified access to all enterprise data. From feature extraction to model training to production, the Molecula feature store provides continuously updated feature access, reuse, and sharing without the need to pre-process data. If you need to deliver unprecedented speed, cost savings, and simplified access to large-scale real-time data, visit dataengineeringpodcast.com/molecula, that's MOLECULA, and request a demo. Mention that you're a Data Engineering Podcast listener and they'll send you a free t-shirt. Your host is Tobias Macy, and today I'm interviewing Julien Le Dem about OpenLineage, a new standard for structuring metadata to enable interoperability across the ecosystem of data management tools. So Julien, can you start by introducing yourself?
Hello, I'm Julien. I guess I've been working in the big data space for the past 14 years. I started at Yahoo, building platform on top of Hadoop. And then I started contributing to open source projects like Pig, and that's how I joined the Twitter data platform team. There I started the Apache Parquet project, and that led to contributing to the launch of the Apache Arrow project later on. And more recently, I was the architect for the data platform at WeWork. After that, I started Datakin, which I'm the CTO now.
And so you've actually been on the show. This is your third time now. So you were on to talk about your work with Apache Parquet, and you were on with Doug Cutting, who was the creator of Avro. So that was a good conversation. And then you were also on to talk about your work with Marquez, which is a natural transition to where you are now with Datakin, which is building on top of that platform. So for folks who listened to the Marquez episode, I don't know if you want to just give a quick recap about where that project has gone and maybe what you're building on top of it with Datakin before we dig into OpenLineage.
Yeah. So, that came from when you build data platform, it quickly becomes evident that you need an equivalent of service-oriented architecture, but for data pipelines, right? Like people consume data and they produce data. And by default, there's very little visibility on where the data is coming from and where it's going. And so we need to understand who consumes the data that we produce and how they're impacted by the changes we may be doing. And we need to understand where the data is coming from that we're consuming and how it's being maintained and delivered, right? So that led us to start the Marquez project at WeWork. So in building the data platform at WeWork, there was this real need for how do we understand in an organization where there are many teams that consume and produce data, how do they understand how they depend on each other and how things change? That was a missing piece in the open source ecosystem. Right. So it's kind of like starting Marquez. And that was the beginning point for starting Datakin. And like, how do we build data observability for data pipelines?
So I know that OpenLineage is also an outgrowth of the work that you've been doing at Datakin and the prior work with Marquez. Can you start by just giving a bit of an overview about what the OpenLineage project is and maybe some of the story behind starting this effort and where it's taken you so far?
Yeah. So while building Marquez, it became obvious that there's a need for standardization of lineage collection, right? Like there are many projects that care about collecting lineage, and there are many projects that produce lineage, right? Whether it's through SQL or Spark, Python, Pandas data frames. There are a lot of projects that produce Lineage, and there are a lot of projects like Atlas, Egeria, Amundsen, Data Hub, Marquez, and other proprietary data catalogs, who are interested in collecting this lineage. So there's lots of duplication of effort on how we extract the lineage for each of those projects. And it makes, first, a lot of duplication, and second, it's very brittle, because by extracting the lineage from the outside of those projects, whenever something changes or to the internal on how they're exposing it, it breaks this extraction. So there's lots of duplication, a lot of wasted effort, a lot of complexity. And so the idea was, let's join forces, right? So we reach out to a large group of contributors and maintainers of those projects, whether in the space of people who are more interested in consuming, like the Data Hub, Egeria, Amundsen, all those projects, or people producing this data, right? Like in the Spark community, in the Pandas community, and like all the SQL related projects. And really, we kind of got together and said like, hey, how do we build this standard in open source? And how do we agree on having a standard way of representing lineage? And so, as soon as those conversations started, it was pretty clear that everybody was like, yes, why don't we have already a standard like this? That's where we started the project. Like, we did a kickoff, have an initial group of contributors and we got the first version of the standard really having a core model of inputs, outputs, and runs of a job and capturing the lineage and having a framework for adding metadata around this core model. And it's really an invitation for all the people who care about lineage to help define this metadata and improve that project.
As far as the state of the ecosystem, you mentioned that each of these different systems are generating metadata, but there isn't really a way for them to be able to communicate that effectively. And then another aspect worth digging into is, so we're talking about Lineage specifically, and I'm wondering, before we dig into sort of the ecosystem piece, if you can kind of differentiate between data lineage and then the broader category of metadata management and sort of how those two are interrelated and sort of the scope of what OpenLineage is trying to accomplish in terms of standardizing, at least the lineage aspect of that metadata format.
Lineage is something we talk a lot about, but I think there are several use cases. So when people talk about lineage, they actually have different conceptions of it because there are fairly different use cases related to what do we do with lineage. So there's one aspect which is more about governance and like understanding how a particular data set or particular column is in a data set is derived from a canonical data source that as a source of truth for defining something. And then there's a lineage in the sense of, I want to know exactly how this data set was derived from this other one, what was the version of the job, and it's more like operational lineage of understanding what happened and how things were transformed. And that led to building products. The tools that care about lineage, they focus on one of those use cases. So they may be focusing on, I want to understand how this particular metric is derived from core data sets, right? So that's one aspect. And others may be caring more about, actually, I want to make sure that those transformations are reliable and happening at the right time and in a reliable way. And those lead to collecting a slightly different version of the lineage and building different use cases on top. And so OpenLineage has been focusing on how do we model those running jobs, right? Because that's a core underlying data that you can build a lot of use cases, like whether you care about privacy or governance or compliance or operations, you need to be able to understand how the running jobs happening. So I think this different point of views on the use cases led to different solutions and makes it difficult to reuse if we don't focus on standardizing and modeling those running jobs and really collecting this metadata. In some way, OpenLineage is a little bit like the EXIF for data pipeline. EXIF is this standard for adding metadata to pictures. So when you take a picture with your digital camera or smartphone, you have your GPS coordinates in it. You'll have the time it was taken. And this is all standardized. And so OpenLineage is a bit the same, right? The best way to capture this metadata about the job and the transformation is doing is when it's running and this information is available. And so this is what OpenLineage is focusing on.
In terms of the actual goals of the OpenLineage effort, there's obviously the need to be able to standardize on the format of some of these core aspects of generating data and processing data. So how are you approaching the actual standardization effort and, identifying what are those core elements and the building blocks for being able to actually generate useful information and just the overall scope of what you're trying to build with this standard? Is it just, some markdown and other people have to go and implement it? Or do you also have reference implementations and code that people can take off the shelf to be able to actually get up and running with it?
The approach to this standardization, I guess, we talk about standard, but it's very different from what a standard body would be doing, right? It's not like one of the goals of OpenLineage has been to not have one big monolithic spec. So the way it's defined is there's a core spec. The way it's encoded is using a JSON schema. So there's kind of a formal representation of what the metadata looks like. And there's a core model that captures just the very simple lineage notion of there's a job and it's uniquely identified by the name. There's an input and output data set that are also uniquely identified by their name. And there's this notion of run, right? So we're expecting there's recurring jobs and there's a run and we know when it started, when it finished, and what data set it read from and what data set it wrote to. And then around that, there's this notion of facet. And a facet is an atomic piece of metadata. Basically, it's its own mini spec. So each facet has its own JSON schema. And what that helps is, as a community, instead of having one big discussion that will move very slowly and one monolithic spec, there's a core spec that's very small and just focusing on lineage. And then we can have a different conversation, very focused conversation on how do we define the schema of a data set? How do we define data quality metrics, data profiling? How do we define column level lineage? How do we define a representation of a query profile, for example? And how do we define the version of a job? So in this model, the nice thing about open source, and the first goal is to agree on a common direction for the project. And then you can have different conversations moving at different speed. So things that are controversial, well, we're going to make sure there's one conversation independently where people can argue in things and find a consensus. And things that are less controversial can move fast because they'll have their own facet to move on. So it's a bit of controlled chaos, like emerges facet, and enabling, really empowering people to drive the efforts they care about. There are people who care about data quality, there are people who care about governance and column level lineage. And these may be different subgroups in the community, and that helps making each of these conversations move faster. So that's kind of one of the goals. And so, the naming of OpenLineage is also drawing the parallel with open telemetry and open tracing, right, which are providing similar effort for the service world. There's a nice parallel because it's really about making a spec, standardizing how lineage and related metadata is exposed. But then, of course, as you mentioned, there's a reference implementation. So OpenLineage provides clients to make it easier to produce OpenLineage events. And there's a reference implementation, which is a Marquez project that consumes and stores and indexes OpenLineage events. And of course, there are several other projects looking into consuming OpenLineage. So today, if you want to use OpenLineage out of the box and you don't have anything, you can start by deploying Marquez. And you can start consuming, and there's several integrations that produce OpenLineage events for Spark, for BigQuery, for Redshift, Snowflake, kind of Spark and Airflow, and the SQL warehouses to start collecting lineage in Marquez. But of course, then OpenLineage is a mechanism that lets you federate this information, right? It can easily be used in different tools or different products that may have a different point of view, right? When we talk about the more governance aspect or the more operation aspects, the fact that there's a standard and exchange of metadata makes it easier for various tools to help you having those different point of views on the lineage data.
In terms of the actual effort of getting this off the ground? I know that when you first published the post that was announcing this effort, there were already a number of other projects and organizations that had signed on to it. Some notable ones that come to mind are Superset, Data Hub, obviously Marquez and Datakin, and you mentioned Airflow. And I'm just wondering how much sort of upfront effort there was in terms of discussing with people what these core building blocks needed to be and sort of agreeing on that core structure before you started writing the specification, or if it was flipped where you started writing the specification and then you got people excited and signed on, and just sort of the process involved there and identifying what are those core elements that are universal enough to be worth keeping into the core specification versus adding into these facets that are, these optional plugins to the metadata information.
Yeah, so we took an approach that was similar to what we did for Apache Arrow. So some years back, contributing to the launch of the Apache Arrow project, and we did a similar approach, which was, let's reach out to all the people we think that are interested by that space or like need this kind of standardization. So, it's a little bit of through the Apache Parquet community and then Apache Arrow community. So reaching out to projects. So I reach out to projects like Data Hub, Amundsen, Pandas project, people in the Spark community, Iceberg, like Data Quality World, like a Great Expectation, or DBT as well. We started by reaching out to people, and like most people I reach out to were agreeing like, yes, we need a standard. Why doesn't that exist already? How do we make it happen? So what we did, we started a group, right? Like started a GitHub mailing list, a Slack channel. And so we started with no spec. So I didn't come with a spec pre-written, but we started by discussing some kind of agreeing on like the core model. And really the initial spec is really minimalistic. So it's on purpose, narrowing it down to just some lineage information, which is the connection between the job names and the dataset names they're reading and writing in a run, right? And so it focused on that, which helped getting to a consensus pretty quickly with this initial group of people. And then a few other people kind of heard about it. Like, so we kind of tweeted about it, we presented about it, and they kind of said, oh, well, we were not part of the initial conversation, but we'd like to join. And in particular, I'd say like the project that have been most drivers in this effort have been like the Edge Area project, which is a project about metadata and governance, like much wider scope of metadata and governance. The DBT folks are very helpful. There's people around the data mesh effort have given a lot of feedback. There's people from the Great Expectation project that are really interested in the data quality aspect of this. And I'm sorry, I apologize in advance for the people I'm forgetting. It's like in every open source project, there are people who are kind of more driver and like pushing the project, and people who are more interested in following and making sure they're on top and they give their feedback. They'll adopt as it gets more steam as well. So it's kind of where we at.
In terms of the actual core model, you mentioned that there's this concept of the entity, and then there are the jobs and the runs. So you had this group of people who were, working together to figure out what are the elements that we need to include in the specification. And I'm just wondering what you've run into as far as any sort of differences in opinion or complexities in terms of figuring out how do you fit this model that needs to be so broadly applicable, but also opinionated enough to be worthwhile. Just figuring out what that balance is, particularly because you have so many people involved who I'm sure have their own opinions as to what's most important and how to represent it and how they might need to consume it. And just the overall process of going from this is a problem that needs to be solved to we have a standard that people are iterating on and actually using somewhere.
Yeah, so one of the design goal of the core model is to really remove impediments from people being able to use it without having to go through like a thorough approval system. So there's also this notion of custom facet. And so there's kind of trade-offs of being able to deal with either being very precise and modeling precisely some the query profile from Snowflake or the query profile from BigQuery or the query profile from Presto, right? So there's one aspect of being very precise and one aspect about having a model that is generic enough so it can represent any of those things in a way that you understand a query profile in a generic way. So this notion of custom facet lets each contributor define their own opinionated version of something, right? Like when you define a query profile, each query engine may have like their own opinionated version of it. And so they'll have the ability to define, this is how we define a query profile. This is how we define column level lineage, or this is how we define, the database, the table scheme. And so that allows them to make their own specific definition in their own namespace. And they own those specs, right? They own that definition. They don't need to get approval from the central project, like get consensus to build them. And then on the other end, there are going to be core facets that are parts of the project spec itself and that define a generic version of this. And so when you publish metadata, it's okay to have some, duplication in the metadata and to have the same information represented in the opinionated version of one of the contributor to the spec, and also have the generic version, which might be a bit lossy, right? Like if you're trying to make a model that will work, a representation of schema that works across all the possible things that exist, it might be a bit lossy, but there's value in have something that is, hey, we have a way of representing schema that makes sense, across everything, and that will deliver value. So there's kind of this trade-off between being very flexible and extensible, where people can add their own facets, and also having core facets that aim to be a more generic representation of things, and that will require more consensus and more conversation. But the good thing about having both is like you can start, like people are not blocked, right? They can start publishing metadata right away from their own point of view and under their own namespace. And then as we collect more of those, it makes it easier as well to build a consensus, right? Because people will already have exposed in a very explicit way, right? They'll have defined a JSON schema for those things. And so there'll be a clear definition of what they're doing, and it will make it easier to arrive to consensus and combine those things and, promote some of those facets to the core spec. So it's kind of the general idea of how we build this in the open source.
And in terms of the actual structure or infrastructure around this, so there's the repository that has the core specification. I know that there's a Python and a Java client for being able to build your own integrations. And then for the actual namespaced facets, I'm curious what the discovery mechanism looks like for being able to propagate that information. Is it something where there's a certain producer, they add that into one of these facets, and then it just kind of exists as part of that data element? And then once you're looking at it on the other side, it's been generated, it's been propagated through your system, it's stored in your system of record for lineage metadata. How do you then discover what that facet model is trying to convey? Like, what are the contextual elements? How do you propagate that? Is that just entirely self-contained and that's part of the specification? Or do you have some sort of central mechanism of being able to look up those namespaced elements and then have, maybe some prose to explain these are what these different attributes are trying to describe?
When you define a facet, you have to provide a JSON schema, and the facet itself has to contain the URL to your JSON schema. So that will let us build a registry of all the facets that exist. So when you build a custom facet, your requirement is to define a JSON schema for it. And as part of the JSON schema, you can add like documentation of the semantics of each of the fields. So of course, you can put constraints of the name of the types, whether they're required or not, any level of nesting, documentation, examples. And so every custom facet will contain a link to the schema that represents it. And that's how we'll be able to, keep track of all the facets that exist, or the custom facets, who define them, and have a registry as part of OpenLineage that keeps track of all of those, right? So you'll have the core facet that their schema will be part of the core spec. And then the custom facet must provide reachable URL with the JSON schema in it.
In terms of the actual concrete implementations of this, particularly in terms of the storage system for this lineage information, what kinds of challenges does it pose by having these arbitrarily structured, arbitrarily nested records, and then being able to actually analyze them and expose them in a meaningful fashion for people who are trying to understand be able to actually build some sort of automation or visualization or intelligence on top of these pieces of metadata, and just, any types of best practices or recommended constraints in terms of, the number of levels of nesting or the specific kind of structuring of attribute names or anything along those lines, to try and build in some sort of commonality and be able to build tooling that is able to take advantage across a number of different facet implementations.
That's the core of OpenLineage is focused on modeling the running jobs, right? So that makes it very reusable, but that's also makes it not geared toward any specific use case on there are people who care about user privacy, right? So they want to be able to track how user private data is consumed and used across pipelines. Or there are people who care about data quality and they want to make sure the data is correct and how it evolves over time and different things like that. So really what this is about, it's about when you receive those events, right? So OpenLineage defines how we're going to model metadata coming from the running jobs. And it's up to the consumer to kind of build those indices and store the data, index the data in a way that's going to make it easy to use for their particular use cases. And so that's where it's important that the models, they represent the data and they're not necessarily optimized for the storage, but there's a spec that defines exactly what it looks like, right? So you can pick which fields you need to index, of how you need to store things to be able to enable various use cases. So Marquez offers a generic representation storage of those facets. And it does index in a specific way some of those fields in particular that it picks, and then it gives a generic access to the list of facets for data sets or for a job. And so you can keep track of also how the metadata change over time. So it's kind of various trade-off, right? So there's a generic way of storing those facets in JSON, and they're defined as JSON. And then the facets you care about, that's where you're going to extract this information using those schema. They'll have a fixed representation, and you'll be able to index it for your use case. And I think this decoupling, it's what makes OpenLineage very reusable, right? When you care about modeling the data, the way you're going to be using it at the time you collect it, that's where you actually losing a lot of information and then making this metadata you're collecting very specific to your use case, right? When you care about dataset to dataset lineage, and that's how you collect the information, and you drop all the information about the job itself, then you lose the ability to use the same metadata you collected for other use cases. So it's really important to be able to decouple and have a clean model of the running jobs. That may not be the exact representation you need for your indexing use case, but that's where you'll have a transformation in between to index it accordingly.
In terms of your experience of going through this process, you're somebody who, as you mentioned, have been working in open source for quite a while, so you're very familiar with that overall process, and you've been working on Marquez and in the data ecosystem, so I'm sure you have a lot of your own opinions and understandings of the various useful aspects of lineage metadata and just metadata in general. But what are some of the ideas or assumptions that you had at the outset of this project that have been revisited or revised as you've iterated through and worked with other people to build out this definition and try to grow the community around it?
Initially, there was this strong need to standardize things. But actually, as we grew, this idea of being flexible and letting people customize things and enabling them to move fast and use the system and add metadata to it without having friction was very important. Also, I think when we think about data processing, there's some nice properties of it that are best practices, jobs should be atomic, meaning that either they succeed and they update the output, or they fail and they don't touch any of the data. And so this atomicity, for example, is not always real, right? It depends how things are done. And we also define those lineage graphs as DAGs, right? This directed acyclic graph, because you only consume from other data set and writes to new data sets, right? And so there's no cycles, which is not true either, right? There are jobs who will read the previous version of the data and then merge it with new data coming in and write back to the same data set, creating cycles in the graph. And this is fine. And, some of those things that need to be part of the model, because especially when you have non-atomic jobs or you have cycles, those are things that can create problems in production. So you want to make sure then you're able to observe those things and have accurate representation of them. So it's kind of some of the assumptions about like a perfect, a spherical data pipeline in a vacuum, so to speak. We had to make sure that the model will actually able to reflect reality and keep track of those imperfections, because those are the ones you want to be able to observe when you're debugging something.
Along that same line, there's a quote, I believe it's from Marshall McLuhan, but I could be wrong, saying, the map is not the terrain. And so in this case, OpenLineage and the lineage metadata is the map. And as you were saying, it's not necessarily a specific, perfect representation of the terrain and the reality of the processing system. And I'm curious if there are any other sort of edge cases or difficulties that you've run into in terms of figuring out, in the real world, this is what's happening, which makes no sense. I don't know how this ever worked, but now I need to figure out how to be able to actually represent this so that I can show it to people so that they can then debug it and fix it.
OpenLineage, somewhat, it builds a map, but it builds a map automatically, right? Like often, you will have diagrams, or people will have pictures of how pipelines depend on each other. Oh, we read from there and you write from there. And the good thing about instrumenting, your schedulers and your pipelines with something like OpenLineage, it's going to automatically draw a map of what's actually running. And so from that perspective, it's going to be more accurate. And it's also going to show you over time how that map has changed, right? And so it's going to be more accurate that, per user drawn map. But of course, there's always limits to this modeling, right? So there's some, in particular at the moment, one of the things we care about is adding more precisions on the partition level dependency, for example, because initially OpenLineage at the core level, it just knows that, this dataset wrote to a table and this other dataset right from that table. And therefore, we kind of inferring that there's a dependency between the previous update and the next update, right? Someone modified it and someone consumed it, and there's a dependency. However, this is not always true. Very often, processing in the data world is incremental and, it's updating one partition at a time. And therefore, a job that updates a partition and another job that reads from a different partition don't depend on each other, right? So it's kind of having more precision like this, of having more precise tracking of dependencies, depending on the use cases, people care about those level of precision. And that's part of the model, right? The model is, if you don't have this level of precision, we'll be able to capture like coarse-grained dependencies, table to job to table. But if you have more precision, like that actually this column depending on this column, you can add a facet that captured more precise dependency at the column level. If you're not reading all the columns from a table, for example, or if you care about more like the incremental processing and capturing the dependency at the partition level, that's also can become a facet on actually when we were reading the input, we were filtering and reading only a subset of the data. On where we were writing to the data set, we were appending a partition, right? And this is a subset of the data that was produced by that run. So this is the level of, depending on the integrations and their level of precision and how much they can introspect the job, they'd be able to extract more information. So typically a SQL job is very explicit about everything it's doing, and the engine knows exactly how each column is derived from something. And something that's more like Pandas or Spark might have more opaque logic that it'd be harder, not all jobs may have the same level of precision. But that's part of the flexibility of the model, to be able to get the precise metadata where you can.
RudderStack's smart customer data pipeline is warehouse first. It builds your customer data warehouse and your identity graph on your data warehouse with support for Snowflake, Google BigQuery, Amazon Redshift, and more. Their SDKs and plugins make event streaming easy, and their integrations with cloud applications like Salesforce and Zendesk help you go beyond event streaming. With RudderStack, you can use all of your customer data to answer more difficult questions and send those insights to your whole customer data stack. Sign up for free at dataengineeringpodcast.com/rudder today. And then another interesting potential complication is you're mentioning, everything is based around this job and the execution of the job, but what do you do when you're working in a streaming system? How do you determine what is the start and end of that job?
Yes, that's a very good point. So OpenLineage, Of course, the goal, people have streaming and batch processing jobs. So the goal is to cover all of those things. So far we made more progress on the batch processing side of things, but definitely streaming jobs are covered by this model. And there are different aspects in which you can cover that. So first, this notion of facet lets you add precise metadata, right? Like there's different notion of a dataset. A dataset could be a table in a warehouse. It could be a folder in an S3 bucket or in HDFS, distributed file system. Or it could be a topic, Kafka broker. Each of those will have slightly different metadata. And same thing about a job, right? A job could be a batch process, a Spark job, or a SQL query. Or it could be, a streaming job, Flink, or Kafka Streams, or Storm, or those different things. And streaming jobs, I know we like to think of streaming jobs as continuously running, but streaming jobs is still being deployed at some point, started at some point, and then they're stopped, and then they're upgraded, and then they're started again, right? So you still have this life cycle of a run. And so you'll have a streaming job and it will have a version of the code in the metadata, and it will have a run starting at certain points using some version of the code. And then when you think of what version of the dataset it's starting from, right? Like if you read from a Kafka topic, well, where you started reading from, the metadata will be the list of offsets, the partition and offsets in those partitions you started reading from. So you can very much model where you started reading this particular run of that particular version of the streaming job. And same thing at the point where it stops, you can start capturing the metadata of what offset it stopped reading and what information, and capturing this information and where it stopped. So it's all about this generic model of having notion of jobs and runs and dataset is pretty stable, and it applies to streaming as well. But of course, the metadata you collect looks different. Whereas this notion of facet, it's, like in the Scala world, people are used to define traits in Java having different interfaces, right? It's about having the ability to add different facets of metadata to those entities. And of course, a Kafka topic has different metadata from warehouse table, but the overall lineage notion very much applies, right? And you'll be able to track, a service writing to a Kafka topic, and then this being archived into an S3 bucket, and then being consumed by a Spark job, and maybe exported in a data warehouse, and then a SQL query goes on it. And it's really important to be able to track lineage across all those layers and be able to understand the metadata that's specific to each of those in understanding what's happening. So I know I've been using a lot of the batch processing use cases as, to explain how this works. But of course, the streaming ecosystem is also covered. And I guess there's more need in the batch world at the moment, so which is why there's been more focus in this area. But there are very much people in the community that are asking those same questions and figuring out how best to model those things for streaming pipelines and capturing the entire lineage graph.
In terms of that, what are some of the problem domains or, types of data or specific maybe industry verticals that are either best suited to using OpenLineage and this, capturing this type of metadata? And, what are some of the problems or use cases that you are explicitly leaving out of scope for OpenLineage?
OpenLineage is specifically focusing on capturing lineage and metadata of running jobs, right? There's something running, it's starting, it's ending, right from this and that. So there's kind of a lot of use cases, like operations, making sure those are reliable, show up on time, and the data is correct is one use case. Another use case is compliance, for example, privacy with GDPR and CCPA, and making sure that, where your user private data is flowing. There's a bit of discovery, what dataset exists and how they're being used or where they're coming from. There's some governance applicable as well, like making sure people use a canonical dataset to derive information from, and they don't go to the wrong version of the data. And then for things that are not covered, I would say that since OpenLineage is focusing on these running jobs, right? There's also metadata that is external to those running jobs, right? People will care about defining somewhere what's a canonical source of truth for the country codes, right? Or for the user IDs. and or who are the stakeholders for a given data set. So this typically doesn't quite fit in the OpenLineage integration because OpenLineage focuses on collecting information from the automated jobs and all of those things, or ad hoc job as well, but not like external kind of metadata to that. However, I think this facet model applies very well. We have actually a lot of questions on the Slack around this is like, hey, how do I add to the model? Who are the stakeholders for a data set? And this is less applicable to OpenLineage, but it's more applicable to something like Marquez, for example. Marquez will care about adding other metadata that are not directly linked to the job itself, but are more like external to that. So it's kind of like the distinction.
For people who already have maybe a data catalog or a metadata management system, or they've already got some set of jobs that they maybe want to integrate to start generating the OpenLineage metadata, what's involved in actually evolving their systems to working well with OpenLineage specification, either as producers of that metadata or storing it and consuming it and integrating it with the rest of their ecosystem?
Yeah, so working with a spec is fairly straightforward, right? This is a JSON schema. So basically it's about producing JSON object that represents your lineage or consuming them depending on which side you are. And we provide, there's a whole built-in like Java Python client, but it's a JSON schema spec. So you can use JSON schema or like related OpenAPI projects to generate client in all the languages. Most languages are supported by JSON schema in general. And so adding integrations and exposing lineage is pretty straightforward. The core model is very simple on purpose, right? And so there are two aspects. So one is if you already have a catalog and you're producing lineage and you have collect lineage and you're interested to expose that to other tools that understand OpenLineage, you can use one of those clients to produce the metadata and forward this metadata to the system. And the other hand, if you're interested in consuming OpenLineage because you already have a data catalog, but you want more lineage coverage, you can easily consume those events that will tell you, this job is running from this data set and writing to this data set and consume that in your model by just consuming those events, right? And so this about understanding JSON events that contain this metadata. One of the advantages of this is to enable federation of tools, right? So you can care about this integration and collecting lineage once and really pushing that into your ecosystem. And then you can have various tools that use this metadata to focus on different use cases, whether it's privacy or operations, governance and compliance and things like that, which I think is very powerful. For example, talking to Edge Area, the Edge Area project is some kind of metadata hub, right? So one feature they're working on is being able to consume OpenLineage and as well produce OpenLineage. So making it easy to kind of synchronize metadata system to make sure like the view of lineage is the same in various systems that focus on different use cases.
Digging more into this federation aspect and the sort of downstream and long-term impact that you think OpenLineage is going to have, I'm curious if you can just talk through sort of your grand vision and your hopes for how this is going to actually play out as the broader data community starts to get on board and adopt OpenLineage and some of the powerful network effects that this will have.
Initially, OpenLineage has a set of integration. There's a Spark integration that collects lineage from Spark. There's Airflow integration that will also collect lineage from the various SQL warehouses offerings. But the way this is happening and talking to various projects, the goal is to push OpenLineage into each of the projects, right? And this is the kind of thing that's slowly happening. But the goal is not to have a central project with all the integration to everything. The goal is each project to be able to expose their own lineage as OpenLineage, and OpenLineage being just a spec. And, it's like a Java interface if you're in the JVM, or just a spec. It doesn't pull in any dependencies to the project, right? It's just having the ability to expose your lineage in a standard representation. And so then at some point, it will become just turnkey in the entire data ecosystem. People will not have to care about how do I extract the lineage from everything, right? Like everything is going to expose Lineage in a standard way already built in, right? Like whatever project, if they use Spark or if they use Flink or if they use a SQL warehouse, they'll have this Lineage exposed and the metadata exposed in a standard way. And so we'll have better tools, right? This is really an opportunity for the data ecosystem to have better tools that give you visibility across everything. So of course, we are building tools for better observability of data pipelines, and other people we care more about governance, and privacy. And I know of people hearing a lot of this privacy by design, right? How we make sure that by design, the user private data never leaks into the places it's not supposed to be, or people think they're not consented that their data is used for, right? And really building that in the system and making it more observable will enable a lot of this. So it's kind of, the end vision data operation perspective for me is really, I have this Maslow hierarchy of needs, right? Like this hierarchy of needs is like before you reach happiness, you need to have shelter, you need to have food, you need to be safe. And when you have those things, then you can care about like reaching happiness and all those things. It's a bit the same about data, right? Like first the data need to show up on time, it needs to be correct. And once you have all those things, then you can actually get value out of it, right? So people joke about how much time it's spent cleaning up the data or like, debugging broken pipelines or making sure we can trust the data. But it's really about building this trust in data and like knowing, you just know, and it's observable and it can be proved that everything is working accordingly, whether it's from an operation perspective and be able to trust the data, or whether it's from like privacy by design, making sure you do the right thing with your user private data, or like being able to prove that you're using the correct source of truth of data to produce certain metrics. A lot of that, right? It's really making everything work better and be reliable, and right? And you can prove it, right? There's not this nagging question is like, but, is this dashboard reflecting what we think is reflecting, right?
Yep.
Or thing like that.
The dreaded sentence of this doesn't look right.
Yes. And maybe it is right and something else is the problem. Right. And maybe it's not right. Right? Like, but if you don't know, it's problematic, right? You can't make a decision.
And so in terms of your experience of working through this OpenLineage spec and working with all these other projects and organizations and integrating this into the work you're doing at Datakin and Marquez, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
I think I'm an engineer. I'm a software engineer, right? So I relate to this, but I think OpenLineage is more of a human problem rather than a technical one, right? It's kind of, when you look at the way people have been building lineage solutions, there's a lot of software engineer like myself. They would rather reverse engineer what others have done rather than, have this conversation, how we would standardize and like make things easy to consume for everyone. And so there's a lot of systems that are very complex because people look at, I can look at the internals of that tools and I can understand how it works and I can extract something without having to ask anybody to change anything, right? And so, which works, right? And they're like a bunch of solutions that exist that solve this particular problem. We will solve the complexity of all the things that exist for you by understanding the intricate details of every one of those things. And the problem with that is it's very brittle, it's very costly, it's very time consuming, and it gets obsoleted, right? As technologies evolves, and like whoever became the lineage solution for Hadoop, now it's kind of like has invested a lot of time in something that's not used as much anymore, right? And so I think it's a lot of a human problem of like, how do we make those conversations happen, right? And like the way that OpenLineage spec is designed is to facilitate those conversations, right? Let's avoid the giant monolithic spec, where is a conversation that will never converge, right? Let's have a lot of small focused conversation on the things we care about. And so that the people who care a particular aspect, let's say it's like table schema or column level lineage, they can help this particular area of the problem move forward, right? And so I think one of the learning is like, when people talk, good things happen. And it's kind of like a lot of OpenLineage is just facilitating making those discussion happens. And when I initially reach out to this group of people and say like a lot of them were like, hey, how come this doesn't exist yet? Well, what we need to know is plant the seed, and then it will happen. There's this interesting children's story, which is a stone soup. So it's kind of someone comes to a village with a pot and they stir hot water, they just heat water and they put a large stone in it and they say, look, I'm making a stone soup. But everybody's welcome to add their own ingredient to it and make it special, right? So basically they're making a soup at nothing, but they're creating this focal point. It's like, look, someone is driving the collaboration, and like the stone soup, the more people come and they put their contribution to it by adding an ingredient, and the more the thing becomes more valuable for everyone, right? So it's kind of really when you think about open source and how we create good incentives, and this is this kind of perfect project where every contribution, no matter how small, is going to make the project better for everyone who's been contributing to it. This is a really good virtuous circle of like how we gain momentum in this project. And everybody's like, yes, this is great. We want to contribute to this because we're part of this effort now. It's valuable to us and it's more valuable for everyone. And I think this is like some of the learnings on open source, for the past 15 years. I guess it reflects a bit some of the projects I've been pushing or driving. It's kind of, hey, how do we standardize this? How do we make this reusable, enable the ecosystem?
Absolutely. And so as you continue to go down this road of building and growing the OpenLineage project, what are some of the things that you have planned for the near to medium term future? And for anybody who's listening, what are some of the ways that they could be most helpful to helping make this effort a success?
There's a couple of directions, right? From a technical perspective, there's evolving the spec, right? Like it's kind of contributing to the facet, and people could be just using it and making their own custom facet or contributing. There's a proposal mechanism on the GitHub that lets you submit a proposal and say like, hey, I think this particular use case is not covered. We need to formalize this. You can see there are several conversations happening in GitHub issues on the project. And so one aspect is helping standardize more facets of the metadata. Another aspect is increasing coverage. Right? Like, how do we adopt OpenLineage? So, there's an existing effort in Spark, but people are welcome to join. And how do we increase the coverage with other projects like Flink, like Beam, like the streaming efforts? The other area is increasing coverage in systems who consume OpenLineage and are able to understand it so that we can help with this federation aspect. So that's kind of how people can contribute and join the conversation. And it's really community-driven spec, right? The goal is really to enable people to contribute and drive the areas they care about. And as part of that, we're in the process of submitting it officially to the LFAI and Data Foundation. It's a sub-foundation of the Linux Foundation that cares about data project. Marquez is part of this project, of this foundation already. And OpenLineage being fairly recent is not officially part of it yet. So it's being submitted soon. And the goal of being part of a foundation is really this testament that, look, this project is not owned by anyone in particular, right? This is a community-driven project. There's a clear governance to it. And the goal is to standardize Lineage and make exchanging Lineage and metadata seamless ecosystems. Like it's we as a data community are making this happen. So it's kind of like in the immediate future, part of having a clear governance. And when you contribute to a project, I think I'm very opinionated about if you have an open source project, there's the license aspect. And like, of course, OpenLineage is Apache 2 license, so it means you can do what you want with it. There's no restriction. The only restriction is you have to give credits, right? You can't claim you did something if you're reusing an Apache project. But then the other aspect is to have a clear governance, and being under a foundation means the license is not going to change, right? Like it's always going to be a community-driven project. And, there's some discussion, you see that happening in some project of like, hey, should we relicense this and protect from someone like using this project? This is not the goal here. The goal is, yes, this is a project that's open source. It's for the community. It's always going to be usable by anyone. And that's why contributing it to a foundation is really important.
Well, for anybody who wants to get involved and get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
So I'm a little biased in that space because I'm building a tool that I think is sorely missed. And, I care a lot about data pipelines, observability, and how to make sure those pipelines are reliable, right? They're running on time, they're producing correct data, and we can very quickly identify what the problems are. Either it's data quality of someone making a change and not understanding the downstream impact of it, or, as part of this, being able to analyze this lineage information and really being able to quickly understand the root cause when there's a problem. But even more than that is just preventing problems altogether by being able to identify the consequences of a change before it gets applied, right? It's kind of, if you're changing the schema of this data set, it's going to impact such and such job downstreams, right? Or this thing is slower than before, or the data set is not showing up on time anymore. How do we quickly troubleshoot and figure out what change upstream make things slower? Or maybe it's just change in data or various aspects like that. And so I think this is very lacking, right? A lot of time is spent figuring out why things are not working quite right. And I think that's a big gap. Yeah, like I said, I'm a bit biased because that's kind of what we're building at DataKin. I think this is extremely important. And I expect that in the future, no data engineer or data scientist will accept a job when they don't have proper tooling to understand how their particular contribution works and is impacted by the wide ecosystems of consuming and producing data set that is around them.
Well, thank you very much for taking the time today to join me and share the work that you're doing at OpenLineage and touch a little bit on the work you're doing at DataKin. It's definitely a very interesting and valuable project, and I appreciate you getting the ball rolling and helping us all by getting this effort out and getting it working. So definitely going to be keeping a close eye on OpenLineage and, hopefully adding my own contributions to making it more part of the ecosystem. So thank you again for your time and energy on that, and I hope you enjoy the rest of your day.
Thank you very much, Tobias. Always a pleasure, and I really enjoyed this podcast. Thank you. Bye-bye.
Thank you. Thank you for listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.